I hope all of you are doing good. Let's start today's chapter, data handling. In our times, a branch of mathematics called statistics is engaged in collection of useful data and its interpretation. There are 5 stages in any statistical study. They are collection of data, organization of data, presentation of data, analysis of data, and interpretation of data. In this chapter, we shall learn organizing to the presentation of data. First, let's learn what is data. Let us have a look at the following list of marks out of 100 scored by 20 students of class 6 in a formative assessment. Okay, these are the marks. So we can see that each entry in the above list is a numerical fact which is known as an observation. Data is collection of facts gathered in the form of numerical values. The collection of observation gathered initially is known as raw data. The raw data listed above gives us a random information about the marks obtained by 20 students. The raw data can be arranged in any one of the following ways: ascending order or descending order. If the above data is arranged in ascending order, we get, okay, and if it is arranged in descending order, then this is the arrangement. So the raw data when put in ascending or descending order of magnitude is known as array or arrayed data. Okay, how to organize data? Let the marks obtained by 35 students in mathematics examination out of 100 marks according to their roll number are as given below. Okay. It is difficult to draw a result from this form of data. It is not easy to find the answer to the following questions. That is, what is the maximum score, what is the minimum score, how many students scored 74 marks, and how many students scored more than 89 marks. Okay. So therefore, to make a result easily understandable and clear, we can tabulate data in the form of table given on next page. In the first column of the table, all marks are written from the lowest to the highest. Now look at the first value in the given raw data and put a bar, that is vertical line, in the second column opposite to it. Now see the second value in the given raw data and put a bar opposite to it in the second column. This process is repeated till all the observation in the given raw data are exhausted. The bars drawn in the second column are called tally marks. See, these are the tally marks. And to facilitate, tally marks are recorded in bunches of 5. The 5th mark is drawn diagonally across the first one. That is 1, 2, 3, 4, and 5 is like this. And 6, 1, 2, 3, 4, 5, 6. Okay. For example, we finally count the number of tally marks corresponding to each observation and write it in the third column, which is number of students, right? So this way of presenting the data is called frequency distribution. Marks are called variate, and the number of students who have scored a particular number of marks is called frequency of the variate. The frequency of an observation is the number of times an observation occurs in the given data. The table is known as the distribution table, as the total number of frequencies equal to the total number of observations. Okay, let's do example 1. Sarah is asked to collect the data of sizes of shoes of students in her class 6. Her findings are recorded in the manner shown below. Okay, now represent this information in a frequency distribution table and then answer the following questions. Okay, first we will prepare the frequency distribution table. After that, we will be able to answer the question. Okay. So first, shoes size are written over here, then tally marks and the number of students. Okay. So the first question is, what is the size of shoes worn by the minimum number of students? Minimum number of students is what? This. Size 8. And what is the size of shoes worn by the maximum number of students? Is this size, which is number 6. Okay. Exercise 24.1. You have to define these terms: observation, data, frequency, and arrayed data. Okay. Pictographs. There are many methods of representing data pictorially. Representation of data by using picture symbols is called a pictograph. See, example 1. Consider the sale of Maruti 800 cars in the city of Delhi in the second half of 2004. The following table explains the sales. Okay. In July, number of vehicles sold 400, in August 350, September 300, October 150, November 250, and in December 200 vehicles were sold. Now the above data can be represented by the following pictograph. Okay, you cannot make 400 pictures or 500 pictures, so we will take a scale. Okay, one picture of this vehicle means 50 vehicles. Okay, so for 400 we will make 8 vehicles. Okay, so in this way we will make the pictures, right? Next is a bar graph. A bar graph is a pictorial representation of the numerical data by a number of bars or rectangles of uniform width erected horizontally or vertically with equal spacing between them. For drawing a bar graph, first we draw two mutually perpendicular lines in the plain paper. The horizontal line is called the x-axis and the vertical line is called y-axis. Normally we use a graph paper on which x and y axes are drawn. While making bar graphs, the following facts should be kept in mind. First, the width of the bars must be uniform in all cases. Number 2, the gap between any two bars be uniform. Number 3, bars can be either horizontal or vertical, right? And number 4, the scale on y-axis must be taken according to the data given. Okay, example 2, as we can see, the following table gives the number of students in our school during academic years 2000 to 2001 to 2004 to 2005. Okay, number of students are given here. So we have to represent this data by a bar graph. So first we'll take a bar graph paper and draw horizontal and vertical lines and name them x and y axis. Okay, you know this is x axis and this is y axis. Okay, so on y axis 1 centimeter is equals to, here we will write on y axis 1 centimeter is equals to 500 students. Okay, so we will start from 500, then 1000, then 1500, then 2000 and so on. Okay, and here on y axis we will mention the year. Okay, academic year. Exercise 24.2. The following table shows the daily production of cars in a factory for 6 days of the week. Represent the above information by a pictograph. Okay, so number of cars 250. You cannot make 250 pictures, right? So what will you do? You can choose any scale. So okay, we'll choose this. This figure is for means 50 what cars. Okay, or you can draw any kind of figure. That means for 250 you will draw how much? 250 divided by 50 is, you will draw 5 figures. Here you will draw 6, for 200 you will draw 4, for 250 you will draw 5 figures, for 204, and then 150 you will draw 3 vehicles, right? Okay students, now you will do practice of the remaining questions.